Hello guys, my name is Nandivardhan Reddy from Information and Technology, bearing roll number of 20951A1248. Today's subject is theory of computation and topic is context-free grammar. Let's we discuss about this context-free grammar. Okay, then come into the topic formalization derivations and Backus north form left and right mode derivation. What is informal comment? A context-free grammar is a notation for decreasing language. It is more powerful than finite automata or regular expression, but still cannot define all possible languages. Useful for nested structures. Example, parentheses in programming languages. Informal comments too. Basic idea is to use variables to stand for set of strings, that is language. These variables are defined recursively in terms of one another. Recursive rules production involves only concatenation. Alternative rules for variable allow union. Example, context-free grammar of for flower brackets of 0 power n and 1 power n slash n greater than or equal to 1. Predictions are s tends to 0, 1 and s tends to 0, s 1. Basic 0, 1 is in the language. Induction. If W is in the language, then SO is OW1. CFG formalization. Terminals equal to symbols of alphabets of the language being defined. Variables equal to non-terminals equal to a finite set of other symbols, each of which represents a language. Short symbol equal the variable whose language is the one being defined. Production. A production has a form variable to string of variables and terminals. Convention. A, comma B, comma C are variables. A, small a, comma small b, comma small c are the terminals. Capital A, capital B, capital C are variables. Small a, small b, small c are terminals. Capital X, capital Y, capital Z are either terminals or variables. Small w, small x, small y, small z are strings of terminals only. Alpha, beta, gamma are the strings of terminals and are variables. Example, formal context-free grammar. Here is a context-free grammar for 0 power n and 1 power n slash n greater than 1. Terminals equal 0, 1. Variables equal to S. Starting symbol equal to capital S. Productions equal to A. Capital S tends to 0, 1. Capital S tends to 0, S 1. Derivation. Intuition. We derive strings in the languages of the C context-free grammar by starting with a starting symbol, and repeatedly replacing some variables and by the right side of one of its productions. That is, the production of A are those that have A on left side or the arrow mark. The derivations of formalization. We say alpha, capital A, beta derives alpha, gamma, beta. If A derives gamma is a production. Example, X derives 0, 1, then S derives 0, S 1. The X equal X derives 0, S 1. So S in place of S we will write again 0, S 1 because this 0, S 1 is already given. So we can replace S in place of 0, S 1. Then we by S we can replace 0, 1. In this way, 000, 111 we get as real. Okay. Here we'll see here what is happening. See, in place of S1 we are placing all this. In place of S it created S1, 0 S1, and in place of 0 S again we kept 1. So in this way we got this. Okay. This thing means 0 or more derivative steps. Basic alpha derives star A from any string alpha. Introduction. If A tends to star B and B tends to gamma, then A tends to star is star gamma. Example, iterated derivation. X tends to 0, 1. X tends to 0, S1. X tends to 0, S1. In place of S, we write 0, S1. Again, in place of S, we write 0, 1. Okay. So, S tends to S tends to star S. S tends to star 0, S1. S tends to star 0, 0, S1, 1, comma. S tends to star 0, 0, 0, 1, 1. Sensational form. Any string of variable and or terminal derived from starting symbol is called a sensational form. Formally, alpha is a sensational form. If S tends to star alpha, language of a grammar. If Z is a context-free grammar, then L of Z, the language of Z is W slash X tends to W star W. Note, we must be a terminal string. S is the starting symbol. Example, Z has productions X tends to epsilon and X tends to 0 epsilon. Then language of L of Z equal to 0 power n and into 1 power n slash n greater than or equal to 0. Here, note this epsilon is a legitimate right side. A context-free language, a language that is defined by some CFG, context-free grammar, is called as context-free language. There are CFLS and context-free languages that are not regular languages, such as the example just given. But not all languages are CFLs. Intuitively, CFLS can count two things, not three. BNF notation. Grammar for programming languages are from written in BNF. Brackets not found. Variables are words in less than and greater than symbol. Example, statement. This less than symbol, statement and greater than symbol. Terminals are often multi-character strings indicated by boldface or underline. Example, while in bold letter or while with underscore. BNF notation. Symbol, semicolon, semicolon, colon equal to is the form used for things to. Symbol slash is used for or. A shorthand for a list of productions with the same list size. Example, S tends to 0 S1 or 0 1 is shorthanded for X tends to 0 X1 and X tends to 0 1. BNF notation. Clean closure. Symbol is used for one or more. Example, digits tends to 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9. Unsigned integer tends to digits. Note, that's not exactly the store of regular expression. Translation. Replace alpha with a new variable, capital A, and production A. A tends to A. Capital A tends to capital A in the alpha. Example of clean closure. Grammar for unsigned integers can be replaced by U tends to UD or D. D tends to 0 or 1 or 2 or 3, 4 or 5 or 6 or 7 or 8 or 9. BNF notation. Uh, optional elements surrounded one or more symbols by close brackets to make them optional. Example, statement tends to if condition, then statement else or else condition. Translation. Replace alpha by a new variable A, capital A with production A tends to A or epsilon. Example of for optional elements. Grammar for if then else can be replaced by X tends to ICTSA or A tends to ES, E into capital S or epsilon. BNF notation. Grouping. Use flower brackets to surround a sequence of symbols that need to be treated as a unit. Typically, they are followed by for one or more. Example, statement list tends to statements of statements. Translation grouping. You may, if you wish, create a new variable A for flower brackets of A. One projection of A tends to A tends to A. Use A in place of flower brackets. Example of grouping. L tends to a flower brackets of S. Then replace by L tends to S of A with A of A to S. A stands for this. Okay. Then L tends to S of B. B tends to A or epsilon. A tends to S. B stands for A open brackets, close brackets, A of square brackets. There are more A. Finally, by L tends to SB, B tends to C of E, C tends to A, AC or A tends to S, C stands for A. Let's move on Nightmost derivations. Derivations allow us to replace any of the variable in a string, leads to many different derivations of the same string. Leads to many different derivations of the string. By forcing the leftmost variable or alternatively the rightmost variable to be replaced, we have this distinction without a difference. Leftmost derivative, say WA alpha tends to LM. Leftmost W beta alpha. If W is a string of terminal only and A tends to beta is a production. Also, alpha tends to left star is star leftmost of beta. If alpha becomes beta by a sequence of 0 or more tends to leftmost derivative of shift. Example of leftmost derivation: balance parenthesis gamma. S tends to capital S R open bracket. S tends to capital S. F tends to S close bracket. This all thus S tends to star LM of brackets inside brackets outside brackets. S tends to this all is a derivation but not a leftmost derivation. Rightmost derivation. Say alpha AW tends to R rightmost derivation alpha beta W. W is a string of terminals only. Alpha tends to beta is a production. Also, alpha tends to star of rightmost derivative of beta if alpha becomes beta by a sequence of 0 or more steps, RM steps. Example are rightmost derivative and balance parenthesis grammar. X tends to SS of S brackets. We can see this all three open brackets are side by side. This is neither a rightmost derivative nor a leftmost derivative. Thank you. This is all about the context free grammar. What we have seen all this leftmost derivative, rightmost derivative grouping. Okay. BNF. What is mean by BNF? BNF is a backness and or form under context free grammar, language of grammar, intentional forms, iterative derivation, formalization. Okay. All this CFD formalization, informal comments, all this we have done. Okay, we have covered all this formalization, derivation, back form, leftmost derivation. Okay. Thank you guys. Thank you.